Hey Algebra 1, we're in Chapter 4 and we're looking at linear functions and relations, and we're in Section 4.2, writing equations in slope-intercept form. We only have one vocabulary term today, and that is linear extrapolation. Linear extrapolation is a big phrase or big title for simply using a linear equation to make predictions about values that are beyond the range of the data. For instance, if I were to up here make a table for, I think we talked recently about my woes with Verizon and the fact that they started me at I would begin by paying $120 for installation fee, and then every month I'd have a monthly bill of over $80 or about $80. And so we saw something like this. I can make this graph to represent, or I could have data that would represent only a few months, right? So 1, 2, 3, 4, 5, 6. Okay, so I can have this data that represents only 6 months, but I could use the equation and the graph, honestly, to extrapolate, to make a prediction of what the cost would be further out. So I could extend my line to figure out what's going on out here at, let's say, 11 months. And I'd extend this axis and I could say, oh, well, I'd be paying, X amount of dollars at that time. So that's really what linear extrapolation is all about. So our first example brings us to the idea of writing an equation given the slope and a point. So we're going to write the equation of a line given the slope and a point, and this is not typically what we usually do. We're not used to this, right? We were really talented when we had only to write the equation of a line given the slope and a y-intercept. So it would be really cool if we can get the y-intercept. That's what I'm thinking right now. So the y-intercept is what I'm looking for. I know that this is the equation of the line y equals mx plus b. I've got m. They gave me the slope. I just need to figure out what the y-intercept is. So I'm going to do that by starting off by putting all the information I know into this equation. You might think you only know very little, but you actually know quite a bit. So we know what the slope is, but we also know something really important, a point that goes into this equation that's going to satisfy this equation. Since this point satisfies this equation, I no longer have a variable for y and x. I know that when x is 2, y is 1, so that's going to help me solve for our b value. So when x is 2, y is 1, so I'm going to put a 1 there. I'm going to put my 2 here for x, and I'll fill the rest out. That's equal to 3 times 2, and I'm going to add to that plus b, and that's what I need to solve for. So if I can get b, I got this equation. So I'm going to do the math. 1 is equal to, don't want to be in red, don't want that. Okay, that's better. 1 is equal to 6 plus b, and we need to solve for b, and we'll see that b indeed is going to be, if I subtract 6 from both sides, we see that b is equal to -5. Since b is equal to -5, we know that our y-intercept is equal to -5. So how does that get us what we want? Well, let's go back to what we talked about. We know that y equals mx plus b is a super beautiful form, and what we can do with that is plug the slope in, plug the y-intercept in, and I have the equation of my line. So my answer is y is equal to 3x, which came from the original problem, but we just worked our tails off to figure out that the y-intercept is a -5, and I did it in red just to be consistent. So 3x minus 5 is our answer. So example 2 is going to give us an opportunity to exercise even more skills. We've got 2 parts, so make sure you leave room. It says the topic that we're talking about is to write an equation given 2 points. The first example is right here. We're going to write an equation of the line passing through the points 3, 1 and 2, 4. So we could draw the picture, but I don't think that's necessary here. Let's think about what we want. So you remember from the last problem that it was really convenient to put the equation in y equals mx plus b form. It was really nice because all we had to do last time was find the y-intercept. But now we've got to find the slope too. which isn't too bad because we remember how to find the slope from our previous chapter, where we know that the slope is the change in y over the change in x. So my slope is the first thing that I'm going to find, and then I'm going to go and find my y-intercept. And we're going to do this part the way we did the last example. So let's look at this first part. So I've got 3, 1, and 2, 4. I'm going to do the change in y. So I like to do 4 minus 1 over the change in x, 2 minus 3. And I get that my slope is 3 over negative 1. So my slope is negative 3. That's the first thing. So I can rewrite my equation like that. Y is equal to negative 3x plus b. Now I need to figure out what this b value is. So I'm going to highlight it here and highlight it here. This is the same process we did before. What did we do last time? We used a point, plugged it in for x and y, and then we only had b as a variable. Now we have 2 points. Does it matter which point? No, and we can see that in our example in a moment. So let's first use the point 3, 1 just to see. You do not have to use both points when doing this problem. You can choose whichever point is most convenient. So we're going to try 3, 1 first. So I'm going to draw an arrow here, and we're going to use that by plugging in 1 for y, and then we'll plug in 3 for x, and we'll solve for b. So when I solve for b in this case, I'm going to have to isolate this variable. So I know I have 1 is equal to negative 9 plus b. And then if I add 9 to both sides, I get that 10 is equal to b. So in this case, when I use this, this point, each time, well, when I use this point, I got that b was equal to 10. And I want you to see that each time we do it, no matter what point we use, as long as it's the point that the line passes through, we'll get the same thing. So let's check it out. So we have 4 is equal to negative 3 times 2. Notice I'm putting the 4 in for y, the 2 in for x, and I'm going to add that to b, and we're going to solve for it. So let's see what we get here. So when I multiply negative 3 times 2, I get a negative 6. So 4 is equal to negative 6 plus b. Scroll up a little bit, and scroll down. And then I'm going to add 6 to both sides. And I think you guys already see what's happening here. I get 10 is equal to b. And so indeed, we see that it doesn't matter which point you use, you will still get the same answer. Of course, we're not done. What we need to do is find the equation, and our equation is y equals mx plus b. Now that we have the slope, we're going to plug it in right here. Boom. When we have the y-intercept, either one will do, which is the same value. We get that there. So my answer is y is equal to negative 3x plus 10. And that's my final answer. All right, so the hard thing with these problems is kind of finding that b term. You got to remember what you're doing. You do not, again, need to use both points. You can choose one and use the one that you find most convenient and easy to use. All right, so let's take a look at example 3. In addition to his weekly salary, Ethan is paid $16 per delivery. Last week, he made 5 deliveries, and his total pay was $215. Write a linear equation to model Ethan's total weekly pay, T, if he makes D deliveries. I know at first this doesn't seem like a slope-intercept form equation, or it doesn't seem like it lends itself to that, but it really, really does. So what we'd like to do is, first let's think about it. The amount that he gets paid, let's call it T, is dependent on 2 things. First, the amount of money that he gets per week, which we didn't talk about, and then the amount of deliveries that he makes, but he's getting like, what, $16 per delivery? So we're going to do 16 times D. When you look at this, I hope you're seeing in your mind y equals mx plus b, because that's really what's going on here. In this case, the y value is the total amount of money that he earns. The d value is really the x value, and the slope is 16. What's missing? What's missing is our y-intercept, and our y-intercept in this particular situation is his base salary. So what we'll do is we'll actually do what we've done in the previous problems. We are going to find his base salary, or in this case, well, what we can refer to it as is the y-intercept. So how can we do that? We don't have a point. but we do. We have the point 5, 215. This point tells me that when D, or X, is equal to 5, the pay, Y, in this case T, is equal to 215. We're going to use that to solve for our Y-intercept, or this term here, the salary. So let's get started. I like using red for this, so let's go ahead and use red. I'm going to just put a little box here, or I could even put B or S for salary, whatever. All right, so I'm going to plug in the values that I have and see if I can solve. T is $215 according to this point, and D is 5 according to this point as well. What we need to do is figure out, what is this? Well, we have all the information we need. So we've got 215 is equal to 16 times 5, 80, plus this mysterious amount that we're looking for. What we'll do is we'll solve this the way we know how. We're going to subtract 80 from both sides of our equation, and we're going to be left with whatever this mysterious thing is. Well, 215 minus 80, and we get that this final amount is 135. So we know that Ethan gets paid, his base salary is $135 a week, and then we get this additional information. We're not done. T is equal to 16 times the deliveries plus the $135 base salary that Ethan gets. Our next example is example 4, but it really directly relates to this example. So I want to try to shrink this out, move it over to the side, and see what we can do looking at example 4. So I'll write example 4 down now. Okay, so what we're asked to do in example 4 is to predict how much money Ethan will earn if he makes 8 deliveries in a week. And this is where we get the vocabulary term linear interpolation. And basically extrapolation, linear extrapolation, which is going to give us the opportunity to extrapolate information that's not really there, a part of what we have. Well, we've got this really cool formula, which is going to really give us everything we need. So 16D plus 135. So we know that deliveries refers to D in this case. So T is equal to 16 times 8 plus 135. So we get 128 plus 135. The next thing we need to do is find the sum, and we get $263 in this case. So after 8 deliveries, Ethan's going to make $263. All right, guys, you have your assignment. Make sure you take a look at these examples and any others if you need it. I'll write the assignment down, and I look forward to seeing you tomorrow.